Okay. Now, in the first function definition, we created a function called modify list with function. So this function takes a list and a function. So a function takes a list and a function that mentally we would like to use this input function to apply onto each one. All right. So for example, it can be stamping onto each picture. It can be signing on each document in the list of documents. It can be performing encryption of each document. So apply function onto each element in the list. So that'd be a great idea. Next time when we want to uh, modify and update each and every element in a list, we simply say modify list with function, supply the list, supply a function. And here is where, if you want to just define run forget, just use a lambda. So let's try this first. So the idea is we just do a quick loop through all the values inside um, inside the list. And because we are going to apply the calculation, we're going to apply this function. This apply function is going to look at the particular value, all right, that is currently being scanned. So for example, take square root. So if we have 2, 3, 4, currently we're at 2, so we take a square root of 2, 1.414, whatnot. And then we're going to store that calculated value into a list. So our A list here is going to be 2 becoming 1.414. 3 will take the square root, it becomes what, 1.73 or whatnot. And then 4 take the square root, becomes 2. So when we return from modify list with func, our A list will become basically all the square roots of the numbers. So let's start with something simple. 5, 6, 7. When we say modify list with func of this list A, and we run a lambda, this lambda says inspect each input element, which is going to be first 5, then 6, then 7, right? Calculate 5 plus 1, so it becomes 6. So 6, 7, and 8. Print A. Let's run it and see. And indeed, we have that, right? Yeah, okay. And then we define a function called add1. Add1, just to see, because must we always use lambda to supply to this input parameter that's called applied func? Not really, because we can, for named functions, you can actually have the advantage of the add1, right? Because it's pointing at the internal lambda. So internally it's stored as lambda, right? But we have add1 pointing at it. And so when we reference add1, it is able to call modify list with func running over 5, 6, 7, because we add 1, we're going to get, no, we already added 1 to A, so if we run again, we get 7, 8, 9. That's right. Then we might say, well, how come you can have a return here? Yeah, because all we need is to supply a function to apply func. Yep, okay. The definition of modify list with func is to expect a function. A function can be fulfilled with a named function like this, with a return, of course, or a lambda, which has an automatic return built in. So that's okay. So it's not to say that, how come I can use return here? Remember, what we said was, if you define lambda, you cannot have return inside. So here, before we run, Spider already says, nope, that's not allowed, right? So that's why you cannot do that. Now, let's try with the if, the expression form of if. So we want to return 0, or let's say 1, if x is less than or equal to 5, right? Otherwise, return 2. And that is okay. So it's a quick scan to see if all the values in the list they will be converted into either 1 or 2. 1 if they're too small, 2 if they are very large, no matter how large. So when we do that, we'll get 1, 2, 2, right? Because 5 is less than or equal to 5, and then the rest are all 2s. And then we add 1, it becomes 2, 3, 3. Now, what if we don't want to change A? Because we want to keep that. That's very important data. What do we do? Do you recall earlier something about pass by reference and making a copy, right? So, right. So here we can say make a copy of A. Remember, copy is a function call, so we have to supply the open close bracket. So make a copy of A and then change whatever values you have on the copy, not the original form. So if this is the case, we can then, of course, check that it is the A copy that is being modified. All right, the original value stays the same. And because the next one we are modifying A directly, not its copy, we get 6, 7, 8. And of course, we can also say, no, we want to preserve A, right? So another copy, all right, will be A dot copy. So here, when we do A dot copy directly, we lose the ability to point at it. We lose the ability to look at that value, that modified value or the original value. So what happens then? We think this is what we want to do, but it is not doing what we want to do. So when we modify, when we make a copy, the modify list with fun will get a copy and it will get 5, 6, 7 as a new copy, right? So it modifies that new copy without changing our own 5, 6, 7. And then after that, throw away. But wait, we did say we assign to a copy too, right? But let me ask you, did modify list with fun return a value? Then we check, oops, it did not. So by default, it returns none, right? So our A copy 2 will have a none sticking right in front of us. Ta-da! So how do we change it? The way we can overcome this is, of course, to make modify list with fun return a list. Now you may say, but the caller already has a list. You don't really have to return, right? You're right. In such cases, for example, when we call it like this, we already made a copy, so we know it's safe, and it will be modifying a underscore copy. That's fine. We have a way to look at that, and we print it out, and it's correct. So we don't have to assign anything that modify list with fun returns because we know it's already a underscore copy. So we just call it. We do not assign it, and it is fortunately okay also for Python to run a function which returns something and you don't catch it. You don't assign it to another variable. That's okay, no problem. The value that is being returned is simply thrown away. Okay. Now, in the second modification, now we have a dire need for the function to return its own A list because when we call a dot copy, it was just created on the fly and then without naming that baby, it's being thrown to modify list with function. It doesn't have a name. So you say, I lost my baby, there's no way to get it back. Fortunately, modify list with fun will groom the baby and return the teenager back to us. All right, so by keeping that return value into A underscore copy 2, we now will be able to see the modified values while A is still intact. Okay, hopefully this will kind of bring in all the different components within a single screen about functions, about lambdas, about passing by reference of structured values, and how to cope with it through copying, and why certain obvious things like caller already has a list. Why do we return a list? Why some of these things are being done? It's being done because in cases where it is not so slightly inefficient, it's very, very little impact. But in cases where if you don't return, there's no way to get it done, then we really appreciate that there is this return of the same value there, right? Okay, so these are just the little things that are not really covered or discussed anywhere else in proper textbooks, but it only comes with a little bit of programming experiments and encountering bugs that we get to see the importance of observing some of these programming rules and a bit of redundancies like these. Okay, okay, so back to our classroom here. Basically, we are done with basic intro, and all these are basic, basically. Basic introduction to function usage, definition, lambdas, and all the gory details about them for you to be able to utilize function mechanism, all right, to build clear, readable, maintainable logic with high productivity, high reusability, and high scalability. Productivity means you do it quicker to achieve the goal. Readability means you make less bugs. More people can use your code and you feel better. And scalability means whenever you need to expand because business is good, because you did good job in your code, it's easily done because it's all modularized, logic is clear, and everything is ready to go into the next league. So all these are unspoken yet very important aspects for you to be able to program well. It is not just hackers that need to be super solid with their codes. In fact, hackers don't follow some of these rules. They go with times where there are good hackers and bad hackers, but that's a different discussion. But by and large, if you want to reap all these good benefits, functions are essential mechanism and components. So I hope you will really master this session and let me know if you have more comments or further questions.